I think Dr. Geete sir is having some problem in net connectivity. So instead of Dr. Geete and Dr. M.S. Vaidya sir, the head of the Department of Animal Genetics and Breeding, College of Veterinary Animal Sciences, he will conduct the next lecture. He is going to introduce the correlation and regression theory. Sir will explain the theoretical part today and will explain the practical example on tomorrow. So I request Dr. M.S. Vaidya sir, kindly check the PPT is visible.
It is visible, sir. Visible.
Okay, thank you, thank you. Dr. Vaidya sir is going to explain the theoretical part of the correlation and regression analysis. Sir, Vaidya sir, please.
Well, thank you, Dr. Sajid Ali sir. Thank you, Dr. Sajid Ali sir. I suppose I am audible also, and you are able to view the screen that I am trying to share with you.
Yes, sir.
Is it visible?
Yes, sir. Yes, sir. It is visible. It is audible also.
Oh, thank you very much. Shall we continue, please?
Yes, sir.
Now, as a part of tomorrow's program, actually we had been supposed to deal with the correlation and regression analysis, but instead it's a standby opportunity, and I think I should continue as the organizers have properly planned. Well, in this case, how is it that I am not able to switch on the slides? Huh? Well, now here in this case, usually the descriptive analysis, it has three dimensions, in the sense that one is univariate analysis, the other is bivariate, and a multiple variate. Variate here, the term explains about the variable, the measurement on which you are going to do some measurements, the factors, the variables which we are supposed to actually measure on different components of the statistical study. Now, usually when we carry out some experimentation, what we try to describe is that what is the shape of that distribution, what is the spread, how far it is spread in terms of the distribution. However, when there are two variates simultaneously under our consideration, we call it as bivariate type of analysis. Similarly, the correlation and the regression, these are the very important components of bivariate analysis in particular. Now, simple normal distribution will only give you a guideline as to how much is the peak, how much is the concentrated distribution near the peak, how much is the wide spread of the distribution. But bivariate will allow you to have some more information, like their association study. Now, from this point of view, let me tell you that we'll go into further details. Like, for example, it's simply a measure of association. Correlation, it is measure of association between two variables. We usually call X and Y. Well, there are two measurements which we have taken on a certain entity, on a certain organism, or a group of individuals, and we have measured there are something like, say, length, breadth, or something like some other parameters which are of our interest. In case of blood, well, maybe different individuals for their regarding the blood constitution, the different components, or many different ways in which we have carried out the measurements on the variable, the variates. So the variables are not simply designated as dependent or independent. They are run together, they are measured together for each of the individuals which we are supposed to. And these two correlations, namely the Spearman's correlation coefficient, which is called as rho, and the Pearson's product moment correlation, or R, these are the usually measured. When calculating the correlation coefficient for normal data, we usually use the Spearman's technique of finding out the correlation. Now, when any change in one variable, it affects the change of the other variable, the two variables are said to be correlated. and the degree of associationship, the degree of relationship, degree of their dependence on each other, or simply their existence, coexistence, gives us an idea about what exactly is the correlation. If we simply plot a graph of those two x and y variables, when we see a rising type of line, we call it as a positive correlation. Similarly, if we see a descending type of a line, in such case we call it as a negative type of correlation. Or when the spread is uncertain, when we are not sure in what way these two x and y entities are related to or associated with each other, in such case we call them as simply zero correlation or no association or no correlation at all. Now, this is general distribution for the x and y bivariates which we are under our consideration. Now, similarly, what exactly does it do? What does correlation indicate? A minus correlation, negative correlation, it indicates simply a negative type of association. That means when there is an increase in the x type of variable, there is a decrease or proportionate reduction in the y type of measurements or the other variable. So such type of correlation is referred to as -1. And similarly, the negative correlation. However, when both the x and the y both are rising, when they are proportionately rising along with each other, in such case we call it as a positive correlation, or it simply indicates a positive or a plus type of correlation among the two variables. The negative correlation, it indicates a sort of an inverse type of relationship, whereas positive correlation indicates a positive type of relationship. And whenever whenever the variables they are associated, they move along with each other. Now, the formula for this Rxy, or the correlation coefficient of correlation, it is something like this. These are usual terms which we have been already familiar with. Covariance of xy is measured. That means that their togetherness is measured, and in the denominator, it is the under root of the variance of x and the variance of y. So covariance, their togetherness divided upon individuals in variance upon the individual x and y variance and their product and their square root. These constitute the actual measurement of the correlation coefficient. Usually, correlation coefficient, or rather, it never exceeds the -1 and the plus sign and the +1. That means they are the maximum limit of correlation is +1, and the minimum limit of the correlation coefficient is -1. Now, how to calculate it? Another way of calculating the correlation coefficient is the finding the how far each of the individual observation for the x variable is away from the mean, and similarly finding out how far is the each individual observation of y which is away from the mean of y. So and their product together, when they are summed up together, it forms the numerator. And in the denominator, what exactly we calculate is the difference or deviation from the mean, their squares and their summation. That means sum of squared deviation as far as for x, and sum of squared deviation as far as it is concerned for the y variable, and their product and their root. So these are the constituents of a correlation coefficient. Now, for testing whether the correlation is significant or not, usually t-test is applied. Now, how this t-test has to be applied? Well, first we have to assume that there has to be a hypothesis to verify that the correlation coefficient is significant. For this purpose, we assume that there is no correlation. So rho is equal to 0. That is our hypothesis. And modulus, whether it is plus sign or minus sign, modulus of the correlation coefficient under root divided by the 1 minus r squared. 1 minus r squared. This constitutes the calculation for the t-test which is required for the verification of the significance or the correlation coefficient. Or in short, the t distribution from the table value for the n minus 2 degrees of freedom, for the n minus 2 degrees of freedom, when the calculated value of this particular expression modulus rho under root divided by under root of 1 minus r square and multiplied by under root of n minus 2, it gives us a perfect idea whether the correlation coefficient is significantly distributed or not. When the calculated value is greater than the table value, the way we have calculated it, obviously we call it as significant, and that means it is there is significant correlation. There is significant correlation, and in the other cases, we call it as the there is no significant correlation. The standard error of the correlation coefficient, it is also used to determine the confidence interval around the particular value of true correlation coefficient, which is to be tested, which is called as the zero. Now, here significant difference if we find from the t-test, obviously we call it as the non-zero correlation or significant correlation, and that can be tested using a t-test, t-statistics as indicated. Now, the other part is regarding the regression. Now, regression, the term regression, it has a meaning that means going or stepping backward, going backward. Now, here, the regression, it gives us as to the level of dependence. Now, it is usually used to examine the relationship when we call that two individuals, two parameters, two traits, two common variables, they are related to each other. We simply get to know only the idea about their associationship. But regression gives us an additional advantage as to in what way these are depending on each other, or how, in what way, what is the degree or the dependence of the degree of dependence, that is also indicated in the regression analysis. Now, once we perform the analysis, it can be used, the same regression formula can be used to predict the dependent variable based on the variation in the independent variable. Now, this additional ability of prediction is very much used in most of the statistical analysis, because we usually have a certain sample in which we carry out the type of analysis, and at the end of sampling, what we try to estimate is the predictive value based on this earlier experience, whether the same can be applied in the nature or not. That can be decided using the regression or the predictive ability of the regression coefficient. Similarly, the regression coefficient, it is a sort of an intuitive level, in the sense that we usually assume that in business, a well-dressed man is thought to be financially successful. However, similarly, a mother knows the more sugar in her children's diet, it may result in higher energy level. That means those children will be more active. So these are simply intuitions, but the proof of correlation or the proof of regression, the proof of statistical analysis only gives us a perfect idea whether whether your intuition can be affirmed, can be confirmed using the statistical analysis only. Usually, in many of the experiments that we carry out, we have a certain hypothesis. We try to test the hypothesis, and our intuition is that feeding something like this in the diet gives us better performance in terms of the experiment of the animals, or their performance, their age, their weight, their body weight, that can be increased or reduced by addition or deletion of certain components. So this type of predictive ability of this regression equation, it gives us an additional advantage over the correlation. Similarly, when we try to plot in terms of graph the value of the dependent variable for all the values of the independent variable, what we call what we carry out usually in case of any type of graph. But the difficulty is that here, how much certain are we? How much certain we are about the estimate, the predictive equation that we have developed based on the regression equation, whether it is fulfilling the requirement, whether it is fulfilling the requirement, and whether it is accommodative, whether it is accommodating all the variables and all the data points which are under consideration. Well, usually it is a point of question, and sometimes, these data sets, these data points, they are slightly different from the type of line, the regression line that we have developed. However, when these data points are away, when these data points are away from the regression line, in such case, their farness, their dependence, or their scattered nature, it indicates that whether the regression will be a valuable tool or not. In such case, the regression model has to be tested based on the minimum squared residuals. Now, how these residuals will come into picture? Usually, in case of a particular regression equation line, y is equal to mx plus c. The m indicates the slope of the line, and c indicates the constant or the intercept on the y-axis. However, each data point is slightly away from the main regression line. Now, in such case, obviously, how far is that particular data point away? When we try to square the residue, when we try to identify the farness of the data points from the line, we actually get the residual, the grand total of the residuals. Now, this residual will determine whether the regression equation is fitting or not. Now, another way of finding out that particular equation is that whether the regression equation is a linear one or a non-linear one. The intercept and slope into x plus error, that is the usual form of expressing a linear regression. Similarly, if the constant is added to the coefficient of regression multiplied by x. Now, in such case, when the coefficient of the regression equation, it is multiplied by the factor of x. Now, in such case, the regression equation becomes non-linear or curvilinear, or it may assume the shape of something like hyperbola or parabola also. Now, in such case, usually it is difficult. Now, whether the regression equation is accurate enough to be used in the predictive models or not, that can be decided based on a particular value, which is called as the R-squared value. Now, here this R-squared value is a very important indicator of the regression equation. So, how this R-squared value will come into picture? In the earlier slide, we discussed about the farness of each individual data point and the ability of the regression equation of obtaining or minimizing the residuals. That means accommodative ability of the regression equation that decides the R-squared value. The more the R-squared value, usually regression or it is expressed in terms of percentage. In such case, higher the R-squared value, it indicates that most of the variation in the dependent variable is explained by the variation in the x or the independent variable. Now, when that R-squared value is 0.49, in such case, we call that 49% or almost 50% of the variation is accommodated in the given particular equation of y is equal to mx plus c, or y is equal to m into x plus the constant and the error term. Now, when the R-squared value is higher, obviously the predictive ability of the regression equation is much more certain and affirmative. Similarly, when the R-squared value is minimum or lower than say 10 or 20%, in such case, the ability of the predictive ability of this regression equation is minimized, and in such case, the utility of the equation gets minimalized, or rather, it gets lowered, and further it cannot be used in the form of a predictive equation also. Now, let us try to simply compare what exactly is the meaning of finding out the differences between the correlation and regression. Now, these are correlation is simply a type of relationship between the two variables, and regression, it is not simply a relationship. It has additional ability of one being independent and the other being the dependent. Now, that relationship is different from the correlationship, where it is simple association. Correlation coefficient usually measures the extent of relationship, whereas the regression coefficient, it is capable of estimating how much will be the change in the dependent due to the change in the unit of one variable or the independent variable. So correlation coefficient is a two-way type of relationship, whereas regression is only a unidirectional or one-way type of relationship. So this is also very important. The correlation coefficient ranges between -1 and +1, whereas the regression equation, the coefficient of regression, it extends from minus to plus infinity. Similarly, the correlation of both the variables are in correlation coefficient, it is the distribution of both the variables are at random, and whereas in case of regression equation, one is independent and the other is dependent. The other variable will be the dependent one. Now, simply for the sake of taking a time out, some codes which are related to particularly the statistics, they have been enumerated here. Just take a thought over it, ponder over it, and see if you can find out some meaningful understanding of, or say better idea with regard to the different statistical terminologies and things which we are likely to cover. Similarly, I have prepared some practical data sets and the distribution in terms of or the methodologies for Excel and also for the SPSS platforms in which we will be able to analyze in the next or the subsequent time allotted to us. But considering the limited availability of time, I have simply enumerated the theoretical part aside, and for the practical assignments, we will be dealing with actual stand-on, hands-on training with the practical data sets and how to find out the relationship in terms of correlation and in terms of regression also, and how to find out the better graphs to represent the exact relationship among these different correlation and the relation type. Now, statistics is usually considered as a different type of simply not art but also science. Well, the scientific things, they will come in the form of different notation, formulas, expression, and all these things. But what it hides is much mesmerizing than what it shows. Always remember. So this is also one of the quote by Benjamin Disraeli. Another quote here, what we have is, do not put faith in what the statistics say until what you have actually examined in what they do not say. Please remember that before planning the experiment, thorough knowledge or say a little more homework of statistics will only add to higher dimensions, higher indicators of your experimental research, and that will only allow us to go into the work more carefully and analyze and draw some inference or some conclusion based on the statistical data, which will be more important. The obvious things will be obviously indicated in the statistical test that we carry out. But there are certain hidden facts, hidden realities that those also come in front of due to experimentation and due to proper type of statistical analysis. At the end, let me conclude that one of the Sanskrit verses, well, it's a very old saying in the Upanishad, and India's contribution to the world of stats, the world of maths is not simply zero. It is much, much more than zero. Here, if we consider zero as the Purna, well, obviously our view will be only restricted to only the science part of it. But there is something beyond science. There is something much, much more than science. When we consider Purna as the infinity, when Purna is considered as an infinity, it has much more things to say when we come to such verses as Purnasya Purnamadaya Purnamayeva Avashishyate. That means it's not 0 minus 0. It obviously there remains something more than 0, something more than 0, and that is very important. So whenever we carry out the experiment, well, it is not the end of it. It is not the end. Rather, it's simply a beginning of science. The statistical analysis only adds to the tool, additional tool, through which we can understand the relationship between the two variables, and furthermore also will be able to incorporate into the scientific attitude that needs to be developed as discussed in the earlier inaugural session. Well, thank you very much. Let me conclude the theoretical part of the presentation, and in the tomorrow's class we shall be able to continue with the practical session or online analysis of the different types of correlation and in what way those can be achieved. Well, thank you, Dr.